All right, today we're going to dive into one of the most epic stories in the entire universe. We're talking about the life, the death, and the incredible legacy of a massive star. It's a story of unimaginable power, cosmic creation, and, believe it or not, it has a surprisingly deep connection to every single one of us. So let me just start by asking you a question. That gold ring on your finger, the iron in your blood, the calcium that makes your bones strong, where does that stuff really come from? Well, the answer isn't a mine, and it's not a pharmacy. It's something way, way more spectacular, and it's the entire point of the story we're telling today.
To answer that, we have to go way back. I mean, all the way back, to the very beginning. You see, every single star, including the massive hero of our story, starts its life in a place called a stellar nursery. It's out here, in the cold and the dark of deep space, that the seeds for new suns get planted. Now, these stellar nurseries are actually these enormous things called molecular clouds. Just try to picture a cloud so vast it stretches for light years across space. It's made up mostly of simple hydrogen gas and a little bit of cosmic dust. This is the raw material, the cosmic lumberyard, for everything that's about to happen.
Okay, so this is where the magic happens. It all starts with gravity. Some little pocket in that huge cloud gets a bit dense, and it starts collapsing in on itself, pulling in more and more material. As it squeezes tighter and tighter, the core heats up, a lot. This glowing hot ball is called a protostar. But then comes the tipping point. When that core hits an absolutely insane temperature, 10 million Kelvin, bam, nuclear fusion suddenly ignites. And in that brilliant flash, a star is officially born. So after that fiery birth, our star settles down for the long haul. It enters its adulthood, a phase that astronomers call the main sequence. This is the longest, most stable part of its life, where it'll spend the vast majority of its existence just, being a star. So what's the secret to all that stability? Well, it's this incredible balancing act called hydrostatic equilibrium. Just think of it like a cosmic tug of war. On one side, you've got the immense force of gravity trying to crush the star completely. And on the other, you have the explosive energy of nuclear fusion pushing outwards. For millions of years, these two forces are in a perfect, deadlocked tie. But here's the twist. Not all stars are created equal. Our star, the hero of this story, is a massive star, more than 8 times the mass of our own sun. And that changes the entire game. It burns through its fuel incredibly fast. I mean, just look at that lifespan. A few million years compared to our sun's 10 billion. This star is living life in the fast lane. And as you can see from its final fate, it's destined for a much, much more dramatic exit. So what does that dramatic end actually look like? Well, it all kicks off when the star starts to run out of its primary fuel, hydrogen, and its core. That perfect balancing act we just talked about, it's over. Gravity starts to get the upper hand, and the star enters the frantic final chapters of its life. As the core contracts and heats up, the star starts to look, well, kind of like a cosmic onion. It begins fusing heavier and heavier elements in different shells or layers. So you've got hydrogen fusing in an outer layer, helium fusing into carbon in the next one, carbon into neon, and so on, all building up around an increasingly dense core. And this is where the pace gets absolutely frantic. Just look at this timeline. Burning hydrogen takes millions of years, right? No big deal. But then, as the elements get heavier, the clock speeds up like crazy. Helium fusion lasts about 500,000 years. Carbon fusion? Only about 600 years. Oxygen fusion, we're down to 6 months. And then silicon, the very last stage, that lasts for about a single day. The star is in a desperate final race against time. It all comes to a screeching halt at iron. Iron is the end of the line. Why? Because every fusion reaction up to this point released energy, pushing back against gravity. But fusing iron actually consumes energy. It sucks the life out of the core. So the star's engine doesn't just run out of fuel, it goes into reverse. The long battle against gravity is officially lost. With absolutely no outward pressure left to support it, the iron core collapses catastrophically. And this triggers the star's final violent act, a supernova, one of the most powerful explosions in the entire universe. The speed of this collapse is it's mind-boggling. In less than 1 second, seriously, in the time it takes to snap your fingers, the core, which was about the size of our entire planet, crushes down into a super dense ball that's only about 20 kilometers across. It's an unbelievably violent and nearly instantaneous event. And the energy that's released? It's just staggering. In just a few seconds, that supernova unleashes more energy than our own sun will produce over its entire 10 billion year lifespan. For a few weeks, that single exploding star can actually outshine its entire galaxy of hundreds of billions of other stars. But here's the most amazing part. This spectacular death isn't just an ending. It is, in fact, a profound act of creation. The star's legacy is what allows for entirely new beginnings all across the cosmos. And here, right here, is the answer to that question from the beginning. The incredible, unimaginable energy of the supernova is what forges and scatters all the heavier elements. The oxygen we breathe, the calcium in our bones, the iron in our blood, not to mention precious things like gold and uranium. It was all created in that final, violent moment and blasted out into space. This is the ultimate cosmic recycling program. All that material from the dead star goes flying out and enriches those huge molecular clouds we started with. It seeds them with the raw materials needed to build the next generation of stars, rocky planets, and, eventually, life itself. The death of one star truly is the seed for countless others. So, the next time you look up at the night sky, remember this. The story of a massive star isn't just some abstract thing happening far, far away. It's our story. It's the story of where we came from. The very atoms that make up you, me, and our entire world were forged in the heart of a star that lived fast and died young. We are, all of us, literally made of stardust.